Hi, I'll go over Lab 8 of ECE 285, which is regarding RC circuit analysis. So for part 1, you have a DC RC circuit, and for part 2, you have an AC RC series circuit. So for the first part, the DC source, what we're going to do is we're going to connect our circuit like that schematic right there, but I'm going to change my resistance to 200K and my capacitance to 100 nanofarad. So with your circuit or the circuit on the diagram on the manual right now, you should have a time constant of roughly 100 milliseconds. For me, my time constant is roughly 20 milliseconds. So when I measure my data, I need to give myself ample enough time for the capacitor to charge that voltage and then as well as discharge the voltage so I can see the waveform properly. So I will pop up my Scopy and connect to my device. While I'm doing that, I will go over my circuit. So here is my 200K, and then here's my 100 nanofarad. My channel 1 is measuring the 100 nanofarad capacitor, and that's all I have connected to my circuit other than like the 5-volt power and then the ground cable, because we only need 5 volts to supply. So if you don't see any squares besides your spectrum analyzer network, signal generator, oscilloscope, you have to disconnect and reconnect because we need the oscilloscope for this measurement without a doubt. So what I'll do first is I'll go under my power supply, make sure it's set to 5 volts and my channel 2, or sorry, my negative output is set to 0, and then switch over to my oscilloscope. So first what I'll do is I'll make sure I give myself enough time to record the data. So like I said, my time constant is 20 milliseconds. So what I'll do is I'll charge my capacitor for about 2 seconds, let it hold a charge for 2 seconds, and then discharge it for 2 seconds. So around 6 seconds, and then I'll give myself about 2 seconds for start time. So that will lead to about 8 seconds roughly. So each block right now is set to be 10 milliseconds. So right now I have 160 milliseconds in total for data collection. That's way too short. So I'm going to increase my time base either in channel 1 or channel 2's settings right there. So I'll just keep increasing it until it's 500. So if you have 500 milliseconds, that's 8 seconds of data collection. For you guys, when you're doing the experiment, you're going to need about closer to like 8 seconds, 9 seconds to get good data. So I would suggest keeping it at 1 second and giving yourself about 3 or even 4 seconds for charging, holding, and discharging. And then also give your system like a second or two to like just relax and start data collection. So right now I have about 8 seconds of data collection. So I'll start my signal, switch over, turn on my power supply, hold it for about 2-3 seconds, stop it. And then now, after about 8 seconds, you'll start seeing your output. And so here we go. So what I'm going to first do is I'm going to increase my voltage per division so that way I can see everything. Or honestly, I'll just shift this down. And then I'm going to disable channel 2 because I'm not really using channel 2. So if I shorten my time base now, I can see that exponential decay and exponential increase. So what I'm going to do first is I'm going to go over here and then I want to measure that time constant, right? So what the time constant says is after one time constant, about 63.2% of that stored voltage should be depleted. So that means if you do 100 minus 63.2, you'll get 36.8%. So that means the capacitor should hold about 36.8% of that initial voltage supplied. So that's what I'll do. So I'll go to my cursor settings by clicking the 2 parallel lines to the right of that text, click on track, and then move my cursors. So let's see which one this is. Doesn't necessarily matter. So this is 2, so I'll keep that one on the right. So I'll go and keep moving this cursor until I see the max voltage that occurs right at CURV1, so cursor 1. So it's holding steady and then it starts dropping after this point. And then I'll move my second cursor until it's 36.8% of that initial voltage. So I'll just calculate that using my calculator real quick. So I will just do 3.094 times 0.369, and that gives me a voltage of 1.14. So I'll try to approximate 1.14 using my second cursor. You probably won't get exactly. If you do, that'd be fantastic. But if you don't, it's understandable. Oh, I was actually very close. There you go. So that's about 1.14. So if I measure that change in time, if I just scroll over to delta t, it doesn't necessarily matter if delta t is negative or positive because it's just a difference in time. But I see that my delta t is about 18, actually it's 19 milliseconds, which means that it is about 1 millisecond off from my theoretical time constant. And that's pretty close to the theoretical calculation. So that data result is very good. So now that's how you can transition into experiment 2 because you're done with the DC portion. And experiment 2 is just sending in an AC signal with a 1 volt peak to peak, actually 2 volts peak to peak, and 100 hertz. So what I'll just do is I'll just go to my signal generator, switch this to 2 volts peak to peak at 100 hertz. And then I'll go ahead and click run. And I'm still measuring the voltage drop across the capacitor. What you could do is you could also measure the input voltage. So that's what I'm going to do right now. So I have channel 2 measuring that input voltage and channel 1 measuring the voltage drop across that capacitor. So if I go ahead and click run, and then switch with my settings because everything is messed up from what I was doing from earlier. So my position, I need to revert back to 0. Okay, that's fine. Okay, make sure you are actually using your yellow cable instead of the red cable. So once you swap that out and do it properly, let me just do a single so that way I can get better data. Okay. Move this off to the side a bit. So yeah, so now if you do that, you'll see just 2 sine waves. One with the purple again is my input voltage. So there is a phase shift between the capacitor and the input voltage, but that is expected. But that is how you do lab 8 of ECE 285. Good luck.